Section 4.6, Fundamental Theorem of Algebra. It's a real short lesson, won't take us but a second to do it. So from section 4.3, we found out that an nth degree function will have at most n real roots. And I talked about this yesterday. We can now make the statement that an nth degree function will have exactly n complex roots. So if you've got a third degree function, you have 3 roots. Some of them are real, some of them complex. Well, actually, all of them are complex because real numbers are complex as well. Also, we discussed that if 2 is a root of a function, this is a little bit of a review. If 2 is a root, then x minus 2 would be a factor. This fact can be extended to complex numbers. If 2 plus 3i is a root, then x minus 2 plus 3i would be a factor. Keep that in mind. 2 is a root, x minus 2 is a factor. 2 plus 3i is a root, x minus 2 plus 3i is a factor. Complex conjugate theorem, I've told you this as well. If a complex number is a root of a function, then its conjugate will also be a root. Imaginary or complex roots come in pairs. If you've got 2 plus 3, like in the previous example, if 2 plus 3i is a root, what else will be a root? 2 minus 3i. Makes sense. They come in pairs. Finding a polynomial, and I think this is well, we got 2 examples, then we're done. Finding a polynomial giving its zeros. Find a polynomial defined by the following information. We have a degree of 3, and I started you out with an easy one. The degree is 3, and the only zeros are 1, 7, and negative 4. Degree 3, 1, 7, and negative 4 are zeros. I'm sorry. So here we go. Degrees 3, 1, 7, and negative 4 are zeros. Are there going to be any other zeros? No, because it's degree 3. Third degree means it has at most 3 real zeros, and all 3 of them here are actually real. So if these are our zeros, can you tell me what our factors are? X minus 1, x minus 7, x plus 4. There's your function. F of x equals x minus 1 times x minus 7 times x plus 4. What about this? Could I do, that's just one of the many answers. Could I put f of x equals 3 times that? Would that also have the same zeros and satisfy degree 3? Sure. What would the 3 do? What would it actually do to the graph? It'd stretch it. 3 times, it'd be 3 times as tall, but here's the thing, you would still have these same zeros, it would just be stretched out. So numbers out front doesn't matter. That's very important that you know that. We could put a negative number out front. A negative number would stretch it and flip it over. But this satisfies this condition. We could multiply those out. If it, let's see, I don't know how it says. If it says to put it in standard form or whatever, we can multiply that out. That would be x squared minus 8x plus 7 times x plus 4, which would be x to the third minus 8x squared plus 7x plus 4x squared minus 32x plus 28, which is x to the third minus 4x squared minus 25x plus 28. And you can see there better, that is third degree. Makes sense. Third degree, 3 roots. I'm not going to multiply them all out, I just wanted to show you that you could if it asks you to. Do 2 at a time. Okay, second example. It says the degree is 3 and the only zeros are 1, negative 1, and 3, but it also gives you the f of 2 is negative 6. And let me show you, I'll show you how that comes into play. So degree is 3. Oops. So that just tells us x to the third power stuff, we're going to have 3 different answers, or 3 different zeros. And they are 1, negative 1, and 3. Negative 1, negative 1, and 3. It's a good thing we don't have more than one lesson. F of x equals x minus 1. Excuse me. X, finish it for me. There's f of x. But you've got to also look at the second part. F of 2 is negative 6. Which means the function that they want, you should be able to plug in 2 for x and get negative 6. Plug 2 into that. What do you get? 2 minus 1 is 1 times 3 times Negative 1. Right, what is that? See any ideas? If you plug 2 into this, you get negative 3. We want to get negative 6. Put a 2 in front of it. Because now plug in 2. You plug in 2 into this, okay, you get negative 3, but 2 times negative 3 would give you that negative 6 that you're looking for. So pretty much it wanted you to do that vertical stretch. Before f of 2 was negative 3, but if you stretch that out 2 times as tall, which is what we did, put the 2 out front, then that would pull it up, or pull it down actually to negative 6 from negative 3. Any questions? And you can multiply that out if you'd like. Next problem. Degree is 2, so we got a parabola here. Zeros include 1 plus I. Degree 2. 0 is 1 plus I. There you go. And it also says f of 0 is 6. It gives you the x or y-intercept actually. F of 0 is 6. Like Brittany said, if 1 plus I is a root, then also 1 minus I. Makes sense. They come in pairs. They come in conjugate pairs. If you have one complex root, then you've also got the other. So watch what I'm doing here. If 2 and 3 were roots, then it would be x minus 2, x minus 3. Now you have x minus 1 plus I and x minus 1 minus I. Yes, that's what I'm going to do next. You have to, let's clean this up. Don't leave these like this because that's just nasty. Because degree 2, it should be a parabola. So let's clean it. So we have x minus 1 plus I would be x, what? Distribute that minus. X minus 1 minus I, and the other one would be x minus 1 plus I. We're going to fold that out. And if you do these right, I think these are pretty neat. If you do these right, watch what happens. X times all of it gives you x squared minus x plus xi. With me? Distributed x. Distribute negative 1 gives you negative x plus 1 minus I. And distribute negative I would be negative xi. And the only reason I put xi is because I did xi here. Negative xi plus I minus I squared. Any questions on how to fold that? Multiply x times everything, multiply negative 1 times everything, multiply negative I times everything, and you have now x squared. Negative x would be minus 2x. Xi cancels with minus xi. Minus I cancels with plus I. Minus I squared would be plus 1, with the plus 1 would be plus 2. F of x equals x squared minus 2x plus 2. If you do it right, do you see that? If you do it right, all your I stuff's gone. But again, we've also got to do f of 0 6. What's f of 0 here? What's f of 0 in this function? Positive 2, because 0 plus 2 is positive 2, so we need 6 instead, so you multiply it by 3. 3x squared minus 2x plus 2. Now when you plug in 0, you get 3 times 2, which is 6. You can fold that or distribute that out. 3x squared minus 6x plus 6. Okay, here you go. We need f of 0 also to be 6. They're just giving you all this information. They say build a function based on this. If you find f of 0 here, just watch for just a second. If you find f of 0 here, you get 0 plus or minus 0 plus 2, which is 2. But we want our f of 0 to be 6. So this stuff, plug in 0 there, you get 2. But we want 6 instead, so multiply a 3